Artificial intelligence has become so powerful that many experts admit they don't fully understand how it works. David Bao, an assistant professor at Northeastern University and director of the National Deep Inference Fabric, explores this mystery in a recent conversation with Yascha Mounk. Their discussion delves into the technology behind AI, why so many computer scientists struggle to grasp its inner workings, and how to embed ethics into these systems. Here's what they uncovered. The core dilemma: AI's rise has exposed a paradox. The more advanced the systems, the less clear their mechanisms become. Traditional AI relied on narrow classifiers, like identifying cats from dogs or positive reviews from negative ones. But modern large language models, LLMs, are fundamentally different. They're open-ended, mimicking human language in ways that go beyond simple yes-no answers. This shift has sparked debates about accountability, transparency, and whether we're building tools we can't truly comprehend. Classifiers versus LLMs. Think of classifiers as detectives solving specific crimes. They're trained to spot differences between two categories, like distinguishing a cat from a dog. LLMs, however, are like storytellers. They learn to generate coherent narratives even when the task isn't explicitly defined. This openness is what makes them so versatile, but also risky. As David explains, classifiers focus on what is different, while LLMs learn how to represent that difference, often relying on shortcuts that can lead to errors. The neural network secret. At the heart of AI lies the neural network, a system inspired by the human brain structure. Each neuron processes inputs, passing signals to others in layers. Training these networks involves a process called backpropagation, where the model adjusts connections based on whether its predictions align with the desired outcome. This iterative refinement is what turns raw data into meaningful patterns. Yet, the complexity of modern networks means we often lack insight into why they make certain decisions, creating a black box problem that raises ethical concerns. Transformers, the game changer. A recent breakthrough, Transformers, revolutionized AI by introducing attention, a mechanism that allows models to weigh relevant information in a sequence. Unlike earlier recurrent networks, which process data one step at a time, Transformers can analyze entire contexts simultaneously. This innovation enabled models to handle conversations, generate text, and even reason about complex tasks. But it also deepened the mystery. How do these systems understand the world if we can't decode their internal logic? The fine line between training and understanding, pre-training and fine-tuning, are critical steps in AI development. Models start by learning from vast datasets, every book, article, and conversation ever written. Then they're refined to excel at specific tasks, like answering questions or writing stories. This dual approach allows AI to absorb broad knowledge while adapting to niche needs. However, the reliance on pre-training data means models can inherit biases or fail to grasp nuanced concepts, raising questions about fairness and accuracy. A call for transparency. David argues that the AI industry's embrace of black box models risks undermining accountability. By prioritizing performance over explainability, we may create systems that are effective but inscrutable. He emphasizes the need for interpretability, techniques to uncover how models make decisions. This isn't just academic. It's essential for ensuring AI aligns with human values. As he puts it, we must ask, can we trust a system we don't understand? The future of AI. The conversation ends with a provocative question. Should we accept AI's opacity as inevitable, or strive for a balance between power and clarity? As AI becomes more integrated into our lives, the answer will shape the future of technology and society. What's your take? Are we ready to embrace the unknown, or should we demand more from our machines?